Hello everyone, welcome to part 4, and I did it in one day because I felt like so. So what we're going to do today is that we're going to implement our new modes on our gun. So as you can see on your top left corner, I can switch my modes. So if we are in a safe mode, it doesn't matter. If I click my button, I cannot press the trigger, as you can see. But once I switch to my semi-automatic, now I can. And as you can hear, the rest sounds. Don't worry, there might be a little delay between the sounds. That's because I'm using the quest link to show you. So if you don't have magazine and you try to reload your gun, like this, you will hear a dry fire sound, and afterwards you just hear regular trigger sounds. So again. And you can do it manually. Not releasing the hand, you can also do it, as you can see. Like this. So once we insert our magazine, we won't be able to shoot 2 because we have not taken our bullet into the chamber. So as you can see now. And now, after the bullet is in, we can shoot. And we have effects, decals, and we can also shoot the cubes. We'll have the knockback from the bullet. And now our decals are vanishing because we have set up our fading. And also, when we have our magazine inside, we can get the bullet into the chamber. So as you can see here, the bullet is inside. We can get our magazine out and shoot our last bullet that is in the chamber. Like this. And now our bullet will not be here. Don't worry if it's here. I know it shouldn't be. We're going to set it up in next part because we will not get that far today. But yeah, that's all we'll do today. In the last part, we had a lot of coding. Particularly, we were doing our slide release and slide grabbing. So we have done some comments here, as you can see. And as well as here, and I hope you understood everything. If no, just feel free to ask any questions you want. Today we're going to do shooting, and it will be the same amount of code, approximately, or even bigger. So let's go ahead to our shooting graph, and here, let's select all the code we have for our gun shoot left. We can right click, collapse nodes, and let's call it left hand fire trigger. Let's actually rename our execution pin. So the first one is for trigger is pressed. The second one is for trigger is not pressed, or it has been cancelled. And afterwards we can double click on our collapse node, get our true and false execution pins to our output, and let's call it like this way. Trigger passed threshold. And for this one, we can copy the same but call it trigger has not passed threshold. And let's go ahead and move the outputs node a little bit lower and connect this pin also to here. And just for the beauty purposes, we can add a reroute node and connect false to here, like this. Hit compile and save. We'll have something like that. Also, let's do the same for here. Right click, collapse nodes. And it's somewhat weird. Let's actually take our input pin to here and this pin to here, like that. And also switch it. So our trigger goes here and our cancelled and completed goes here. And we can copy the name from our left hand, but rename it to our right hand. And rename it the same way as here. So trigger is pressed, then trigger is not pressed. And our output pins, we also connect true and false pins to here. So the same way we're moving our outputs nodes lower and connect the result of our trigger is not pressed and cancelled row to here. Speaking about threshold, guys, so don't forget to set it to 0.8. It means that we have to press 80% of our trigger to actually initiate shooting. Be free to make 90% or maybe full 100%, it doesn't matter. And we can also add a reroute node, like that. And hit compile and save. And let's go ahead and rename the output values. So let's actually go ahead and create switching gun modes for our gun. So we can create another graph and call it switching gun modes. So as you remember, on grabbing, we have created our mapping context called IMC weapon right and weapon left. So in those mapping contexts, we have our input actions called switch gun mode left and switch gun mode right. IA switch gun mode right, like this. Before going into details, we have to create our gun modes. We'll use enumerators for this, so let's go ahead and collapse our guns. Go to our guns folder, we'll see our 2 enums here. We can right click, create enumerator, so go to blueprint, enumeration. We can go with enum, firing modes, like this. Let's double click on it. So here we'll add 4 enumerators. The first one is safe. then semi-automatic, then full auto, and first one is just single shot. It's like our bolt. Semi-automatic is like our handgun, full auto is like our M4, and single is for snipers, and etc. And also we can mix them. So let's go back to our gun, Control-Shift-S. We're going to create 3 more variables. So let's go ahead, we'll have our current firing mode. It will be on our gun, and it will be of a type firing mode. Sorry, firing modes. Then we're going to create our firing modes variable. That will be the variable that will store the amount of firing modes we have. So what I would suggest doing is to switch it to the array type of firing modes. So we could choose what firing modes exactly our gun can have. And afterwards, we're going to create another variable. We can call it current firing mode index. We'll use this variable to go through our firing modes. It's like index in an array. So let's switch it to integer. And it will be of a type single. Let's hit compile and save. So on our switch gun mode left and switch gun mode right, we're going to create a function that switches our gun mode. So let's go ahead to our functions, click create, and let's call it switch gun mode. And in addition to this, we're going to add one more function, and let's call it has firing modes. Because before switching and actually creating our gun, we need to see if we have added our firing modes to our gun, because we'll do it manually. So let's go ahead and get our firing modes like this, check if its length is bigger than 0. And we can return this Boolean variable to our return node. Like this. And let's call it has at least one firing mode. Like this. And we should make this function pure. Okay, we can go ahead to our switch gun mode. First step we have to do is to check if our gun has firing mode. So let's go ahead and create a branch. Afterwards, we need to get our firing modes array. We are going to our length. We're getting -1. Subtract 1. Because we are trying to get our last index. And we check if this last index equals to current firing mode. So if our current firing mode index is the last index in our array, it means that we're currently on our single. Our next firing mode will be safe again. So that's the essential check we have to do. And let's also create a branch. And trip in from here, we connect here. So in case we are, and we are currently on our last mode, we have to switch back to our safe mode. So let's go ahead and get firing modes again. We get zeros element, and we set it to our current firing mode, like this, on trip in. And we are setting our current firing mode index to 0, since we are now on the safe mode, and safe mode is our zeros element. But in case we're not in our last firing mode, we're going to get our firing mode index. We're going to increment it like this and set it back to our current firing mode index. And afterwards, we're going to get our firing modes array. We're going to get our current firing mode index element and assign it to current firing mode. And let's just go ahead and print our current firing mode. So we can go ahead and get our current firing mode. We can have a print statement. We connect both of those outputs here. And current firing mode, we just output. Like this. In case we don't have any firing modes, we need to bring a debug message, so print. And let's say gun has no firing modes. And let's expand it and make it a red color, like an error. And also, let's go ahead to our event begin play, so event graph and event begin play. And here, we're going to check also if we don't have any firing modes. So, has firing modes, branch, connect event begin play to this branch. And in case it's false, we're going to print string. We're going to let our user know that there are no firing modes added to the gun. And let's make it red too. And let's go back to our switching gun modes graph. And on our switch gun mode left and switch gun mode right, we're going to use our function switch gun mode like this. And we're going to do it on completed. It means our button has been released and pressed. Afterwards, as you remember also, we have our input action for dropping our magazine from our gun. So let's go ahead and create those ones. And also rename our graph for switching gun mode / releasing mag. And here, IA drop mag left and IA drop mag right. And also we're going to do all the actions on our completed. So we're going to retrieve our magazine right here. We are converting it to validated again. And on completed, we're connecting those variables. So once we release our magazine, we play out sound. We set it up in previous tutorial. Then we're going to get our magazine, get its mesh, magazine mesh. Can delete this node. And we're going to set simulate physics to on, since we're releasing our magazine. And let's actually, before setting our simulate physics, we'll detach it from component it means that it will detach from everything it is attached to. In our case, it's attached to gun, and we're just going to keep it world. And scale rule, also keep it world. Then we connect it to here. We can create some reroute nodes, just so it looked more beautiful, like this. And afterwards, we are going to get its curl grab component. We're going to get our magazine again, get its curl grab component, like this. And we're going to use the function unbind all events from ungrabbed, like this. Because we remember, once we insert our magazine, if we're going to attachment handling, we bind on special event once we grab it. But once we are releasing our magazine using a button, we need also to unbind all the events we have to prevent some weird physics afterwards. So let's go back, simulate physics. We're going to set it to true, like this. And afterwards, we're going to clear the reference for magazine since we no longer have it, like this. Okay, so now, once we have our gun in the level and we try to simulate, we can see that no firing modes added to the gun. So what we'll have to do is to go back to our blueprint and look for firing modes. And we have to set this variable to public, like this, and hit compile. And also, we can do it instance editable, and I think it's automatically here. Go back to our level, and as we can see here, we have our firing modes. So let's go ahead and add for our gun. Let's say if it's going to be safe mode and it's going to be semi-automatic. So if I go ahead now and jump to the game, I go ahead, grab our gun and press changing modes. As you can see on top, we are changing our modes. So now we are on our semi-automatic, but once I switch our mode, we are on safe, on semi-automatic, and so on. And also if we take our gun and take our magazine, insert it, and we decided to drop it, as you can see, it successfully does. I'll do it one more time, like this. And also if we take our gun and take our magazine, insert it, and we decided to drop it, as you can see, it successfully does. I'll do it one more time, like this. Alright, now is the most interesting part and the last hardest part. So we can go to our shooting graph, and now we are going to work on our shooting. So let's go ahead and check if we have our firing modes. So has firing modes, because we don't want to shoot if we don't have any firing modes. That's going to be weird. Let's create a branch. So this trigger pass threshold here happens when we are actually past threshold, and it means that we have to shoot our gun. So let's go ahead and connect this pin trigger pass threshold to here and trigger pass threshold to here, since we are responsible for our both hands. And what I would do is I would actually create a reroute node to make it look more beautiful, as usual, like that. And now we are going to switch in our current firing mode. Switch. Because there is different logic for our semi-automatic and for our full auto. So let's go ahead and connect the true pin to here. And we're going to work on our semi-automatic because it's for our pistol. Afterwards, we'll do the full auto. Since our triggered is called every frame, we need some kind of Boolean variable to communicate with when our gun is shot or no. So now it's essential to create another Boolean variable called trigger pressed, because that's how we're going to communicate with our logic. So bullet has shot, so our trigger pressed Boolean is true. So we press the trigger, our trigger is pressed to true. We shoot, and after we shot our pistol and get our trigger back to its initial position, we set our trigger pressed to false. Afterwards, we need this trigger pressed, and we're going to get a branch here and connect semi-automatic, since we're doing for our gun again. So we'll shoot if our trigger pressed before shooting was false, right? So from the false pin, we're going to set our trigger pressed to true, because now after this moment, we're going to initiate our shooting. Now we can create a function called SingleShot, and let's actually connect this function here like this. And also we need to set our trigger pressed to false when we are not in our threshold. So for our left and right hand, we have a pin called trigger has not passed threshold. In this case, we're going to create also one reroute node like this, and we are going to set our trigger passed, copy it from here, to false. By default, our trigger pressed is false. And once we go through the threshold, it's still false. We need to check that it's false here, but not true. And after this, we set it to true and we perform a shot. That allows us to shoot only one time per our trigger pressed, even though our triggered here is played every frame. Once our action value right or left is less than our threshold, we are setting our trigger press to false, meaning that we are able to shoot again. So let's go and double click on our single shot. And here we're going to have a lot of Boolean checks also. So we need to get our magazine. That's the first thing we have to do everywhere to check if we have magazine. Convert it to validated again. And in case it's valid, we need to check if our chamber has bullet. So let's look for our variable, chamber has bullet. we create a branch and connect this valid pin to here. And let's create a reroute node. So after this branch, we're going to duplicate it and do the same for the case when our magazine is not valid. So let's say checking if we have bullet in the chamber. The same for here, like this, so we could read it. Afterwards, we're going to make a functionality for when we should do dry fire or empty trigger sound. When we don't have the bullet in the chamber, we need to play our dry sound or we need to play our dry shot sound. So let's go ahead and check if we have to dry fire. Dry fire, branch, connect the false pin from here and the false pin from here. And let's create a reroute node like this. So in case our dry fire is false, we're going to place sound in location. Our location will be trigger mesh because we are playing it on a trigger. Get world location connected to here. And our sound for this will have to actually create another sound cue. So let's duplicate this, for instance, and call it empty trigger sound. And we can go ahead to our submachine gun folder, in our guns folder, and go to audio, go to submachine gun safety change cue, and delete whatever we have here and drag this sound here, like this. And also we can insert a modulator. It will sound better. Let's see. Okay, yeah, it sounds better. Now we can go back to our gun and set our newly created variables sound to submachine gun safety change cue and click compile. And let's drag it here and connect it to the sound. And it will be on a false. And in case it's true, we're also going to copy this node. We're going to play different sound. We're going to play our dry fire sound. So it's the variable from our previous tutorial. We can grab it here, connect it here. And the place we're going to play it is going to be also our trigger mesh. So let's connect true pin to here. And afterwards, in case we have performed our dry fire, we have to set our dry fire back to false. Like this. And what I would suggest doing is that actually selected here, right click, collapse nodes. And let's call this node dry fire / empty trigger sound. And let's connect it to our output nodes like this here. Okay, hit compile, save, go back. So afterwards, in case we have our magazine and we have chamber in the bullet, we're going to check if our magazine is empty. So we're going to get our magazine, get is empty, create a branch, and the true pin here, we connect the true pin here. And afterwards, we need to check if our slider is released. So let's go ahead, find the variable slide released, and create another branch. So here, in case our magazine is empty and our slider is released, we also need to create two branches in this case, because our magazine can be empty and can be not empty. So two branches and slider release we connect here. And now pay a little bit attention, because if we have our magazine, we have the bullet in the chamber, our magazine is not empty, and our slider is not released, we're going to play dry fire or empty sound trigger, like this. But in case our magazine is not empty and slider is released, it means we're not holding the slider, we're going to get our magazine and remove round. That's when we are shooting, so we need to remove round. So now we need to create a function. So let's go ahead to our functions, create new one, and we're going to call it line trace, impact, decals, and randomizing recoil. Hit compile and save. So in here, we'll have to create another functions. So let's start with another function. We will call it line trace from barrel, like this. And in this function, we need to create another function called gun location and direction. Okay, so enough of creating functions for now. We'll make this function pure. So as we remember, in our gun mesh, we have a lot of sockets, right? So the socket for the silencer, barrel, ejector, and magazine. Now we're going to make functionality for each of them. However, I know we don't have silencer. We're going to make it later on. So let's go ahead, get our gun mesh. We are going to get different sockets location, and we're going to choose which one to shoot from based if we have silencer or no. So get socket location. We're going to have 3 of them. So if we have socket barrel, that's this socket right here. We can have our silencer barrel. It's the socket right here. And we're going to have another barrel. I'll explain it why we need it later. So let's connect it here. And now we need to create our Boolean variable called silencer attached. And let's actually get it and select vector based on our silencer attached. In case our silencer attached is true, we pick our A. So it means our silencer barrel should go here. And let's actually change the way they are sorted. And in case silencer is not attached, we choose B, like this. It means that we're shooting from our barrel. And sorry, instead of get socket location, we need to get socket rotation. And here we're going to have our barrel. So from here, we need to calculate which direction we should shoot. So we can get forward vector. We're going to multiply it by float. And our float will be the input from our gun location and direction. So let's go ahead, create an input called distance. And it's going to be of type float. And we're going to connect it here. And let's move it like this. The result, we're going to add to our select vector like this. And afterwards, let's actually make a reroute node here. And we're going to add our return node. Like here. Connect this to this pin. So this result will be our direction. And this intermediate value here, before adding, is going to be our location. And let's actually make the location the first one in the list, like this. Hit compile and save. So we can come back to our line trace from barrel function, and we're going to perform line trace by channel. Our channel is going to be visibility, because we want to hit everything we see, and our trace start, we connect here as an input variable, and end we connect also to the input as input variable. And afterwards, we get a return node. We return all the information about the hit. Hit compile and save. So let's go back to our line trace, impact decals, and randomizing recoil function. And the first function here is going to be line trace from barrel, and start and end is going to be gun location and direction. So our location is going to be start, and our direction is going to be end, like this. And that's the first function on our list. Afterwards, we're going to do our impact decals. We can go to our global folder and go to materials, and we will see bullet decals. So if you put it in your level, you will not see anything. It will be something weird. So let's actually go ahead to our material and fix it. As you can see, we have two errors here. So let's go to our first texture sample and select T underline bullet impact H. And here, since it's going to the normal, we're going to select T underscore bullet impact N and hit apply and save. Now, if we go ahead in our level, we put it here and we make it a little bit smaller, you'll see that is actually a bullet impact. If you're building for Oculus device, it's not going to be rendered when you build the game. So be careful with this, but I'll anyway show you how to do it. Let's go ahead to our BP gun, to our line trace, impact decals, and randomizing recoil function. And we're going to create another function called impact decals. Is the input, we'll have our hit from our line trace. Let's go ahead and have hit result as input. What we can do here is we can break hit result. We can extend the list. And what we should find here is our physical material. And we're going to get its surface type and switch in it. So why we need our surface material is that you can have different impact decals and different sounds based on the material you are hitting. If you go to your edit and project settings, you can type surface in your search bar. And as you can see here, we have a lot of physical surfaces. Surface type 1, surface type 2, surface type 3, and so on. So our default is going to be any default surface you want, but you can go ahead and add any surfaces you want. For instance, our flash surface, like a skin body when you're hitting someone, or something like glass, metal, stones, etc. So our default is just going to be default. I'll do for default, but go ahead and add your own surfaces. Go ahead and close it for now. So as you can see, we have only one default. So on default, I will add another function, and let's call it bullet default hit decal. And let's go one level back. So we'll use this function right here on default. So as hit component, we can create an input. It will be of type primitive component, and we can connect our hit component to here. Afterwards, we're going to create two vectors. So their type will be vectors. The first one will be hit location. And the second one will be our normal. So hit location is going to be our impact point, and our normal is going to be our normal. So now hit compile, save, go back to our bullet default hit decal. And in here, our normal will have to use a function called rotation from X vector, like this. So on the execution pin, we use a function spawn decal attached. Our decal will be our bullet decal, so bullet decal. Our decal size is going to be X2, Y2, Z2. Attached to component, we're going to get our hit component. Our location is going to be location from our input, and rotation from X vector is going to be our rotation. Lifespan is going to be 10 seconds, so it means after 10 seconds, it's going to vanish. Afterwards, our return value, we need to check if it's valid. So now we want our bullet to smoothly disappear from our game. So let's actually go ahead and do functionality for this. So we're going to get return value from our spawn decal attached, and we're going to set fade screen size to 0.001 second. Afterwards, we're going to create our set fade in. Set fade in, our start delay is going to be 0 seconds and duration is going to be 0.01. And afterwards, we set our fade out to 15 seconds with the start delay. And our duration is going to be also 15 seconds. And make sure you remove the destroy owner after fade. Okay, we can hit compile and save. We can go back to our line trace, impact decals, and randomizing recoil and put impact decals here, like this. So afterwards, we'll create our function for randomizing recoil. So go ahead, create a new function, randomize recoil. We'll use this function to randomize recoil. So we'll have different recoils when we are holding our hand with the second grab and when we are not having our secondary grab. So for now, we're just going to use our regular recoil because we have not implemented our second grab yet, which we're going to do later, and create two float variables called random recoil Y and random recoil Z. So for randomization of our recoil, we'll select random float in range from minus 0.25 to 0.25, and we'll assign it to random recoil Y, like this. And we can copy this node, and for random recoil Z, we can set up our from 0 to 0.25 and set it for random recoil Z. So again, we're setting those variables just for recoil when we are not holding our guns with two hands. So hit compile and save. And sorry, those are the values for our gun when we are holding with two hands. So actually, let's make it a little bit more diverse. Let's have minus 0.65 here. Here, we're going to have 0.65. Here, we're going to have from 0 to 0.75, like this. And let's hit compile and save. We can even comment it out. Extreme values if gun is only grabbed by one hand. Recoil is less stable, like this, and make it black. I hate white colors. Hit compile and save. So going back to our function, we can grab our newly created function, randomize recoil, to this row. Afterwards, we can create our damage seed, but I don't know if you're going to have damage in your game, but you likely are. So let's create another function and let's call it random damage seed. In this function, we're going to select random integer in range from 0 to 100. I'll prefer using random damage. Return node and connect the return value from here. And let's call it random seed. Hit compile and save. Go back to our function, put it here. Now we're going to create another function, impact sound. So as input of this function, we're going to have our hit result, and we're going to break it. So we're going to check if it's blocking hit, means something is blocking our bullet. And also we're going to change in our surface type. So physical material, surface type, and switch. Since we have only one physical material, we're going to spawn system at location. And now our task is to create a Niagara system for our bullet impact. So I don't want to really waste our time on really creating the Niagara system for this. So I'll go ahead and I'll share a ready system for you so you didn't have to go through all of this. So for our tutorial, for this tutorial, I'll link a folder on my Google Drive. So what you'll have to do to open this folder and then to open your guns folder, right click, show in Explorer, like this. Then we're going to our guns. Then we're going to our global. We're going to our meshes. And we're going to our meshes in our downloaded folder. We're going to copy this, Control C and Control V here. Afterwards, we're going to do the same with our audio and sounds here. We're going to copy this, Control C, and here we Control V. And finally, we're going to copy the VFX folder, Control C and Control V in our project folder. And also don't panic out if you see more files than you have to, because I am adding them throughout the video. Once I'll need more files from this folder, I'll tell you. Like this. We can close everything, come back here. And as we are going to see, we will have a VFX folder with our system. So let's actually open it and see if everything is working. So as you can see now, something weird is happening. So to fix this, we'll go to our sprite render and we're going to select our smoke material. You can just type smoke and you'll see this. Here, we're also going to select our smoke as a material. And as you can see, it still renders in the wrong way. So let's go to our material smoke. And as we can see here, we have our texture sample. So we're going ahead to our texture and select our smoke, tiled D. And here, we're going to select our smoke, sub V, and hit apply and save. Now we return to our bullet impact, so we'll see the smoke input VFX. Afterwards, we're going to fix our debris. So let's go to the first debris, click on mesh render, select debris, chunk 0.1. Here, we do the same, go to mesh render, select debris, chunk 2. Here, we go to our mesh render, select debris, chunk 3. And now as you can see, it looks like our bullet impact. So let's hit Ctrl S, go back to our gun. And here, our system template, we can actually select from system templates, and our index is going to be our surface type. So since we have only one default material, as I've said earlier, you can add your own. We'll select our system is going to be bullet impact, and we'll connect it on true pin. And I don't know why I switching on the material, I can delete it. So our location will be our impact point. We connect it right here as a location, like this. Then our rotation will be our impact normal rotation from X vector. And it will be our rotation. Our scale will leave as it is. And afterwards, we need to spawn a sound. Spawn sound at location. we are also going to select our sound based on our surface type, and our sound will be impact sound. And now we have to create our sound. So let's go ahead to our template, go to global audio. So let's go ahead on our bullet impact concrete, right click, create Q, bullet impact, default. We are going to double click on it, make some space between, add a modulator, and connect here. In the modulator, let's go ahead and make a little bit more of a difference right here. Yeah, okay, it's good. And now we can create in our output, and we are going to create our attenuation settings. So this is how our sound gets overlapped with walls and basically the transformation of the sound based on the environment you're in. So let's go ahead, click here, create attenuation. We can save guns, global, audio, and we can call it bullet impact attenuation, like this. We can double click on it. So all we have to change here is our inner radius right here, and it's going to be 25. And our fall of distance, I prefer to have 3000. We can Control S, go to our BP gun again, and here we're going to select our asset, impact default, with the Q, like this. Our attenuation settings will have our newly created bullet impact attenuation, so our volume multiplier will be 2, and here, our location is going to be this impact point. So we can drag from this pin right here, create a reroute node, like this, and collapse this one. Now we're done with this function. Let's hit Control S and compile, go back. We can drag this function here, impact sounds and particles, and let's actually change this long function name since we're adding sounds and sounds. And afterwards, last function, it's going to be also a damage function. We can add a damage here, too, like this. So let's go ahead and create another function. You can call it apply physics and damage. So this function will be a little bit big. So as an input, we'll have our damage seed is going to be seed, and it's going to be of the type integer, and we're going to have our hit result like this, hit result. So what we're going to do, we're going to break our hit result, and we're going to check if we have hit something like this. On our seed, we can go ahead and promote to a variable like this. So now for something to receive damage, if you have any characters, you can go ahead and create an interface. That's how we're going to communicate between our damage system. So we can go ahead in our guns, right click, blueprint interface, and let's call it BPI damage. Let's double click on it, and we can call it bullet damage. Bullet damage. In this function, we're going to have input as integer damage seed, integer. We're going to have another input. It's going to be our hit bone, in case you have any characters, so we'll have it of type name. Afterwards, we're going to have our impulse. That's our hit impulse from the bullet. It will be of type vector. Then we're going to have our damage multiplier. It's going to be of type float. And then we'll have our instigator. That's who have sent damage. And it will be of type pawn, like this. We can hit compile and save. Go back to our gun. And the next essential check is to see if our hit actor does implement interface our BPI damage. And it's going to be another branch, like this. So in case it's someone who implements BPI damage, we're going to get this hit actor and call bullet damage. So it's in case it implements this interface. That's the function from our interface. And it's going to be on true. So we can make it like this. So our damage seed is going to be our seed. Our bone name is going to be our bone name. We can also make it like this. Then we have to create a variable for our gun called damage. We'll assign it to float. Maybe let's say it's going to be 2 by default. Why it's going to be 2? You may say it's too little because it's damage multiplier. It's not a damage, so let's even rename it damage multiplier and connect it here. And it's going to be 2 as default. And our instigator is get player pawn, like this. So now we have to calculate our impulse. We can go ahead, get our impact normal, create one reroute node, create second reroute node, and we're going to create one more float variable. It's going to be of type impact force. And our impact force is going to be minus 1000 by default. You can change those values to your game. I'm just taking what I have. We're going to multiply it by our impact force. So to float impact force divided by 2. And we're going to plug it here like this. And that's going to be our impulse. Hit compile, save. So that's our damage. So let's call it damage and maybe put it to red like this. You can go ahead and make it look beautiful. I'm just not wasting time on this for now. And if it doesn't implement interface, it means like it's a regular object. So we can go ahead, copy this piece of code here, connect our impact normal to this pin right here. And we need to check that the component we hit is simulating physics. So is simulating physics. So in case it does, we're going to connect it to false. And in case it simulates physics, it means that we can apply our physics. We're going to get its same component we have hit. So let's create a reroute node here. We're going to add impulse here on true. And as we have calculated our impulse, it's going to be this one right here. Our bow name is none and velocity change is false. Also, we will add our return node like this. Also hit compile and save. Go back to your graph and add this function to here. And add a return node. Oh, okay, that was a lot of work. And now our random seed, we connect here our hit result from our line trace, we connect our impact decals, we connect to impact sound and particles, and we connect it to hit result to apply damage. And make sure you set your distance to our gun location and direction, so that's the distance your gun can shoot. So in my case, it's going to be 2000. Now we can hit compile and save. Now let's go back to our graph with our shooting. Double click on left hand fire trigger. So what we are going to do now is we're going to make a protection from our safety because we don't want to press the trigger when our firing mode is safe. So let's go ahead, move this to the right, get our current firing mode, switch, and we're going to set our action value left in all the cases except for save. So let's do something like that. Okay, and we can copy this, put it on the bottom, and do the same here. Like this. And we can go back one level and do the same for the hand right. Move it a little bit to the right, Control V, trigger is pressed. We're doing everything except for save, and same for here. Like this. Now we can go to our single shot function that we've been working on. And in here, in case it's true from this node and from this node, we're going to use our line trace impact decals, randomizing recoil and sound and damage. So we connect it to true pin. We duplicate this function. We connect it for this one. And we have to create another function just to store some initial variables for our recoil. Let's call it store gun location and rotation. So let's go ahead here, get our gun mesh, get a relative location, and get relative rotation. That's for our recoil. So we can go ahead, promote it to a variable, like this. And this one we can promote to a variable too, like this. And create a return node. Okay, compile and go back. We're going to use this function right here. And also, don't forget to connect this branch true node to here. Click compile and save. Remember, we're in safe mode. As we're trying to pull our trigger, we cannot do this. As we're turning on our mode to semi-automatic, we can do it now. And as you can hear, once we press the trigger, we have a sound. And once we use our slide, we have dry fire sound. And after this, we have regular trigger sounds. Again. Okay, let's insert our magazine. Remember, we are in semi-automatic mode. Now we cannot shoot. We have to actually get the bullet in our chamber. Like this. And now, if we shoot, you can see impact decals, effects, trigger, but there is no recoil and fire sound, fire effects, bullets throwing out of the chamber. So, and also, if we hit our cube, we can see that our physics is applied and our decals are there. And now our decals are vanishing because we have set up our fading. So yeah, we have a shooting ability right now, and let's actually continue.